Good morning, my lovely kiddos and my future mathematicians. Today we are on page 32 and maybe 42 and maybe 43. We're going to continue talking about literal equations. We're going to see some funky ones today. So our first one is going to be capital C equals 5/9 times capital F minus 32. This is actually the formula used to convert between Celsius and Fahrenheit. And we're going to be solving for that capital F or Fahrenheit here. All right, so the first thing we want to do here is we're going to notice we're drawing a line down the center of our equal sign, circling the variable that we want to solve for. But I want us to notice that this 5/9 is just not just being multiplied by the f, but is also being multiplied by that negative 32 because it is being distributed. Now we could distribute it and eventually end up having to divide by it. I think since this is a nasty fraction, it would be a lot easier to just divide off that 5/9. But remember, when we divide fractions, we're not really dividing. We are really multiplying the flipped version or the reciprocal 9/5. So the C becomes a 9/5 C. Multiplied by 5/9, multiplied by 9/5. Those are going to cancel because they go to 1, leaving us with just those insides of the parentheses, capital F minus 32. And then from there, to get rid of this negative 32, we are going to add 32 once on each side of the equal sign. The 9/5 and the 32 are not like terms, so we're just going to write those right next to each other. Bring down the F because we did not add or subtract anything from it. And then negative 32 plus 32, those are going to cancel because they go to 0. Number 2. Now, number 2 is kind of fun because there are 2 ways that we can do it. It is a capital I is equal to a capital P times R times T, and we are solving for R, of course, right in the middle. So we're going to draw a line through our equal sign, and we're going to circle the variable we want to solve for. Now, to this R, we are multiplying P and multiplying T. So we could either do these one step at a time, which we'll do first. We're going to first divide by that P. I and P are not like terms, so this just stays as a fraction, I over P. Multiply by P, divide by P, those are going to cancel because they go to 1, leaving us with just the R and the T. Ooh, I made that capital on accident. Okay, and then like I said, we are also multiplying by T, so we're going to divide by T as well, once on each side. Now this, a fraction within a fraction, that looks funny. But when we're dividing the same thing twice, they actually end up being multiplied in the denominator. I divided by P times T, multiply by T, divide by T, those cancel because they go to 1, leaving us with just that R. Now the second way we could have done this is to notice that since we are multiplying both P and T by that R, to divide by P and T in one step. Then the P's would cancel, the T's would cancel, so we'd get that fraction that we found equals our R. So we could have done it in just one step, even though we are undoing 2 pieces of multiplication, but doing it in 2 separate steps is totally fine. Number 3. Let me do that. Number 3, we have 2 times x plus k times x equals m, and we are solving for x. Now this is something we haven't seen before. Our variable is in 2 places. So we're going to draw a line through our equal sign, and we're going to circle our x both times. Now I think it's really important for us to note that these are like terms. Our variables have the same power, and of course they're both x. We have the same variable, same power, so these are like terms. Now, this is just a side note over here. If we did have some like terms like 2x plus 4x, what we would do is add the coefficients and just get 6x. But 2 and k are not, we cannot combine those. So the way that we're going to do this, and I'll use this example first, is we're just going to write our coefficients next to each other and then multiply it by x, which would still give us that simplified version. But since we cannot simplify the 2 and the k, we're going to leave it in those parentheses. So we have 2 plus k, and all of that is multiplied by x. And if we were to distribute the x, we would get back to our original step as well. So we have not changed anything. Then just bring down that m. Now to our x, we are multiplying these coefficients. So to get rid of these coefficients, we are going to divide by this chunk once on each side of the equal sign. Multiply by this chunk 2 plus k, divide by the chunk 2 plus k. Those are going to cancel because that whole thing goes to 1, leaving us with just an x. And then 2, k, and m, those are not like terms, so they are just going to stay in that fraction. Number 4. We have S is equal to 2 times L times W plus 2 times L times H plus 2 times W times H. Oh, I wrote that in cursive on accident. And we are going to be solving for L. And the reason why I wrote my L's in cursive is so we don't think it's a 1. So we're going to do the same thing that we did before. Draw a line through our equal sign, and we're going to circle those L's because we want to solve for those. So we can see that we have 3 terms, and only 2 of them have the L. So before we pull out our L like we did in the last problem, I want to get rid of this term. Since we are adding 2 times W times H, to get rid of that, we are simply going to subtract that whole thing, 2WH, once on each side of the equal sign. S and 2WH are not like terms, so they are just going to go next to each other. S minus 2 times W times H. And now we can pull out our coefficients here. So we are going to have parentheses 2W, which is the piece without the L, plus 2H, which is again the piece without the L. And those are both multiplied by the L. Again, if we were to distribute, we would end up with our original step. And just like the last one, we're going to divide out by that coefficient 2W plus 2H once on each side of the equal sign. Since none of this mess, none of it is like terms, we are just going to bring that whole thing down. And then multiply by 2 times W plus 2 times H, divide by 2 times W plus 2 times H. That whole mess is going to go to 1, leaving us with just that L, which is what we wanted to solve for. Okay, it looks like we will be using page 43, so I'm going to go ahead and flip my page. Number 5. We have something a lot easier. A equals V minus X all over T, and we are solving for V. All right, so if we remember from yesterday, we had those types of equations way back when it was like x plus 2 divided by 4 equals 6. And in order to get up into the numerator, we had to get rid of that denominator, that anchor first. So just like that, we are going to have to get rid of our denominator first before we can get into our numerator. And the way that we get rid of our denominator, which is division, is to multiply it by once on each side of the equal sign. Remember, I forgot to line and circle. Remember, we can keep that multiplication dot between our 2 variables. I prefer not to, so I'm just going to write the t right next to the a. And then multiply by t, divide by t, those are going to cancel because they go to 1, leaving us with just v minus x. Now to solve for v, we have to get rid of that x. Since it is negative, we're going to add x once on each side of the equal sign. Since t, a, and x, none of those are like terms, we're just going to write them right next to each other. Ta plus x. Bring down our v because we did not add or subtract anything from that. And negative x plus x, those are going to cancel because they go to 0. And our last problem today, which is still kind of gross, number 6, we have capital F equals capital G times M times N, all divided by D squared. And of course, since I'm mean and evil, we are going to be solving for D. Not D squared, just D. So we're going to have to figure out how are we going to deal with that squared as well. All right, let me center this. All right, so the first thing I'm going to do is I'm going to draw that line, and I'm going to circle what we want to solve for, which is that D. And notice that I'm not circling the squared. I don't want the D squared. I just want the singular D. Okay? So from here, the first thing that I notice what we're doing to this D is that we're squaring it. It is being divided by M and N, and it is being multiplied by the G. Now, just like the first problem that we did, we could distribute this G, but it would be a lot easier if we just divided out by that G starting out. F and G are not like terms, so it is going to stay as a fraction, F over G. And then now we have our inside of our parentheses, mn over d squared. Now, to get rid of that denominator, we are going to have to multiply by d squared once on each side of the equal sign. But this d squared is being multiplied by f and g, so we're going to put that in some parentheses. Multiply by d squared, divide by d squared, those are going to cancel because they go to 1. So we have d squared times f over g equals mn. Now, again, we want to get d squared by itself before we can get d by itself. So instead of focusing on our right side, now we're going to focus on our left side. So to this d squared, we are multiplying the fraction. So to get rid of that, we are going to divide by the fraction f over g. And this looks kind of funky, a fraction within a fraction. So there are a couple other ways that we could write this. I'll explain that in just 2 seconds here. Multiply by f over g, divide by f over g. Those are going to cancel because they go to 1, leaving us with just that d squared, which is what we wanted to isolate first. Now, instead of leaving this as a fraction over a fraction, I'm going to first write it with our division symbol. And that kind of looks a little better. But it's still saying the same thing, m times n divided by f divided by g. So we know that when we divide by a fraction, we're really multiplying by our reciprocal. So we have mn times g over f. So we flip that fraction and change it to multiplication. And if you want to be really fancy, we could say mng all divided by f and make it one singular fraction. I'm going to put that down here. mng all over f. All right, now this last step is kind of tricky. In order to get rid of this square, we're going to have to use this function called a square root that looks kind of like a long division sign, but also a check mark. So we are going to take the square root of each side. The square root and the square, those cancel out, leaving us with just the d that we wanted to isolate. And since none of these are like terms, this cannot be simplified. It is just going to stay the square root of that nasty fraction m times n times g all over f.